Some of the more complicated problems for simplifying radicals will be in our day 2 notes. Problem 1. If we have the square root of something inside of the fourth root of something, basically I want to refresh our minds as to what that means in terms of exponents. So I have 2 to the 15th times x to the 20th, and that's to the 1/2 power, and then to the 1/4 power. So if I have all of that, remember that if I have the 1/2 power and the 1/4 power, I can kind of multiply those exponents together, just as something that we learned at the beginning of the last night's video. So that's like 2 to the 15th times x to the 20th to the 1/8 power. Now I know we're not expected to do a bunch with that right now, but what that does mean is that I can rewrite this problem as the 8th root of 2 to the 15th times x to the 20th. And that will help me solve this radical problem a whole lot easier. So if I have something to the 4th power and something to the 2nd power, or sorry, the 4th root and the 2nd root, I can turn it into the 8th root. So if I look at this, this is 2 to the 8th and 2 to the 7th. And I have x to the 8th, x to the 8th, and x to the 4th. So what I have is I have 1, 2 on the outside. I can have an x squared on the outside. Then I have an 8th root of 2 to the 7th, which is 2, 4, 8, 16, 32, 64, 128. And then x to the 4th. So that would be my final answer there. Number 2, if I have a cubed root and a square root, that ends up being a 6th root of 128. So 128 is really 64 times 2. 64 is 2 to the 6th. So I can pull 1, 2 out, and I have the 6th root of 2 as what's left over. Problem 3, if I have complex fractions, well, not complex, but yeah, it's complex fractions with a radical in there, I need to try and make this as simple as possible. So what I probably want to do, just like last chapter, is multiply through by the common denominator. So I'm going to multiply by the FFU root 7 over root 7. So 3 times root 7 is 3 root 7. 4 over root 7 times root 7 is 4. In the bottom, the denominator, it ends up being 4 root 7 minus 3. Now, in order to finish this problem, I have to understand what's actually happening. I have a radical in the denominator, and I'm not allowed to deal with that. I'm not allowed to have that in my final answer. So let's take a side step from number 3 and move on to number 4. In order to deal with a problem like this, I want to choose a smart FFU, and let's go all the way back to when we had imaginary numbers. I would use the conjugate in order to eliminate the I. Well, if I want to eliminate a radical, I can likewise use the conjugate. So I'm going to use 4 minus the square root of 5. If I use that, the numerator in number 4 becomes 4 minus root 5. The denominator becomes 16 minus 4 root 5 plus 4 root 5. That's one of the benefits of the conjugate. The middle terms cancel out. So if I have minus 4 root 5 plus 4 root 5, the radicals are going to cancel. And then I have minus root 5 times root 5, which is minus 5. So the denominator is 11. And that's my final answer for number 4. Since I know that now, I'm going to come back to problem number 3. I'm going to choose an intelligent FFU. So 4 root 7 plus 3 is going to be the FFU that I choose. So as I distribute the denominator, 4 root 7 is, when I multiply it by itself, that becomes 4 times 4 times 7, because root 7 times root 7 is just 7. So 4 times 4 times 7 is the same thing as 16 times 7, which is 160 minus 21. So that would be 100. 160 minus 21 would be 139, I'm pretty sure. Then these terms cancel. Then I have minus 9, so the denominator is 130. And if I mess that up with my mental math, then hopefully somebody tells me and I'll add a subtitle for next year. So as I multiply this out, 3 times 4 times 7 ends up being 12 times 7, which is 84. And then I have plus 16 root 7 plus 9 root 7 plus 12. So my final answer for this problem, I'll write it down in the bottom corner, is going to be 96 plus 25 root 7 all over 130. And there's nothing that divides all of those numbers. Number 5, I'll multiply by root 2 over root 2. So I end up with 2, because root 2 times root 2 is 2, plus 3. Oh, this is going to work out real nice. Over 2 minus 7. That worked out great. So I have 5 over negative 5, which is negative 1. Bet you didn't think that was going to happen. Okay, now in number 6, the fufu I'm going to choose is 2 minus root 5 over 2 minus root 5. So the denominator ends up being 4 minus 5, which is negative 1. The numerator ends up being 6 minus 2 root 7 minus 3 root 5 plus root 35. I can't simplify the numerator at all. So since I'm dividing everything by negative 1, it's probably easier to just change the signs of everything. So it's minus 6 plus 2 root 7 plus 3 root 5 minus root 35.